Okay, so longest palindromic path in graph, we're given an integer n, undirected graph, uh, which is represented using array of edges, and this is straightforward. We are also given a label which is of length n, and it represents the character associated with that particular node. We can start from any node and visit each node at most once, so we can't repeat a node, and we need to return the maximum possible length of a palindrome that can be formed by visiting a set of unique nodes along a valid path, right? So if you look at the constraint, we have 14, which is very small. And if you look at one of the example here, suppose we start from 0, we move to 1, and we move to 2. We form ABA, which is a palindrome, and that's the largest that we can form. We return the length, right? Here we can't form any palindrome, just a single palindrome, so length 1. Here n is equal to 4, so here we can form BCB, and that's 3. That's what we return. So if we look at it in a different way, if we forget about the graph aspect of it, and if we consider a similar example like B, C, B, B, A, C, right? Suppose something like this. Yeah, something like this, right? In this case, what's the largest palindrome? I guess this is the largest palindrome, right? Length will be 6, and if this array we were given and we were asked to find the longest palindrome that we can form, I guess this is one of the question. I think it's one of the question from Leetcode, where we have an array and we return the length of the longest palindrome, right? So what we used to do in that problem, which is again based on constraints very much hinting towards dynamic programming, and in dynamic programming what we do is we consider every element as the center of a palindrome, right? If we consider this to be the center, there's nothing on the left, so I can't really extend it beyond just 1. Here we can consider C as the center, but we can't move forward because B and A are different. Here if we consider A as the center, we are missing one thing. I'll let you know in just a minute. If we consider A as the palindrome, there's nothing. B as a palindrome, nothing. B as a palindrome at the center, nothing, and nothing, and nothing, right? So we don't really get anything if we consider it just a single center, right? But there are two things, right, in palindrome: even length and odd length. If it is odd length, something like BAB, in this case the center one is alone, there is nothing to do, nothing matching with the center one, right? I don't know why the tab is not working. Okay, so there is no other A, right? So if we consider that, that is what we have considered right now, right? All the cases with odd length. But if we consider even length, then we need 2 to be the center, right, in order to begin, because they can't be a single element alone in an even length one, right? Just something like AB, BA, right? So here if we consider this to be the center, we can't really extend it. Here we can extend it by this much. If we consider this to be the center, then we don't really extend it. If we consider this to be the center, then we get the longest palindrome, right? If we extend that idea here in this problem, if we create a adjacency list using the edges, right, and we traverse through the nodes from 0 to n minus 1, whatever we have, and every node that we consider, we already have the adjacency list, so we know the neighboring nodes, right? We can easily consider this case. This case is very easy because we consider that particular node to be the center, and then we call the function, which is our dp function, where we recursively extend the nodes, right? So we have two pointers, in this case two nodes in our recursive function or in our dp function, right? So states will be at least two node 1, this will be the left node or something, like ith pointer, and node 2, this is the right node or jth pointer. And we can consider extending it, right? We have to extend it, we don't have any choice, we have to extend it. And how are we going to extend it? Since these two nodes are neighbors and they are already connected, right? So in this case, if we extend it from node 1 to basically moving the ith pointer to some other node neighboring to it, this should not be considered as the neighboring node because we have already visited, right? This is what we have as the jth pointer. So we have to make sure that we are considering both of them as visited and then moving our ith and jth pointer to the next node, right? So we need something to mark that, and that can be any node from 0 to n, right? And if we see that n is very small and is so small that we can even mask it, right? We can use masking and consider 14 bits, that is going to be somewhere around 16 and 160k or something, if I'm not wrong, or actually I think 1.6 into 10 power 5 or something like that. So it's very much feasible to mask those bits or those nodes in terms of zeros and ones. 0 means we have not yet visited it, 1 means we have visited. And by the way, this recursive call will be called for each case, right? For this case, I'm passing node 1 and node 2, and both of them should be same, in the sense the label of both of the nodes should be same. And then when we expand only when the label of both the nodes are same, right? So based on that we expand and then we memoize it. So this is straightforward, probably more clear, it will get more clear, or I guess the idea will be more clear when we code this up. So let me clarify the steps. So the first thing is build the adjacency list. Second thing is we iterate through nodes, uh, consider two cases, one for odd length and the other for even length. For the even length one, for even length, run a loop of neighbors from adjacency list, and for all cases call the dp slash recursive function. States will be the ith pointer, let's call that node 1, the jth pointer, let's call that node 2, and the mask will be initially based on the case. If it is odd length, then the mask will be that particular node as visited, that is bit 1, and all the others bit 0. For this one, the two nodes that we are considering for even length should be visited and all the others should be 0, and then we memoize it later. right? So let's do this. So adjacency list, simple vector of length. This will be of size n. I'll traverse through the edges. Both are, I mean, they are undirected. So 0 will be pushed back with edge of 1, and this will be the opposite. Answer will be 1 initially, because of the fact that we have at least one node. So if you have one node and 0 edges, then we don't really do this. If we consider answer as 0, then we also not iterate through the nodes, and I guess we should start this as 1, and we then traverse through the nodes, right? And that will be from 0 to n, I mean 0 to n minus 1, and then we take the odd length case because we don't really have to get the neighbors, we just have to start using this particular node. So my answer will be maximized based on this. Let's call this a solve function. This will be our dp function. We will pass node 1 and node 2. We pass the adjacency list. We will pass node 1, that will be I. We pass node 2, that will be I. We pass the mask, which will be 0, but it will be I mean the bit will be changed to 1 at the position I, right? So basically I'm doing a OR with 1 at the ith position. So this is our mask, and let's pass the label, and I guess we are good. But since we are considering odd length, this will take pairs and get me the list of all the count of pairs that we get, but I'll add 1 because I am starting with the center one, right? So now for the even length, right? Let's go with the even length. For that we need to traverse through the neighbors, and that will be something like, let's call this J. That will be through the adjacency list from this node, and sorry. Uh, so adj of ij is going to be the node that we are considering, and we will only consider it if the label of both of them are same. So label of adj of ij is equal to label of I. If that's the case, then we maximize our answer using the solve function. We pass adj, we pass I as the one ith node, and j as the adj of ijth node, okay? And this time the mask will be this. Along with this, we also need at the position adj of ij a bit 1 is needed. So let me switch it up, or let's call this, what is it? I'm sorry. Yeah, this. So we are shifting 1 by this position so that we switch that bit to 1, right? So this is it. Now we can I think yeah, I think we are good. We pass label, I'm sorry, we have to pass the label. Let me see if I'm 0, or this is the right packet. Yeah, this is the right, this is label, and I think we are good with this main function. We return the answer here, and we we create the solve function. Solve function is going to return an integer that's going to be the count of the length of the longest palindrome. This will be the adjacency list. Let me copy this. This will be node 1, this will be node 2, this will be mask, this will be label, and that is a string, right? And we are good with the solve function, at least the declaration of it. Now let's have a answer. That's what we are going to start with. This answer is going to return the length of the pairs that we get. I mean, the center is already decided here, so actually we need to add 2 here because we are selecting 2 as the center, 2 things as a center, and this solve function is going to get the remaining length. For that, we are going to change the ith and the jth pointer, that is node 1 and node 2, to the 2 different nodes which are having the label as same, right? So basically we are expanding their neighbors, expanding to their neighbors, adj of node 1 dot size, I don't know why it's lagging a bit. So this is j, this is j, this is node 2, and this is also j. So here we are going to make sure that this particular node that we are moving to, that is the ith pointer that we are moving to. Let me also clarify this. Node 1 is the ith pointer that we are considering, and node 2 is the jth pointer. So I am going to check if the pointer that we are moving to is already visited. If it's visited, then we continue. We don't move forward to the other loop. So basically, if mask of so basically the position adj of node 1 of I, if this position, let me clean it a bit. If this position is a 1, then we continue. Otherwise, we come here, and the node that we are deciding, that is the jth node, we will check the same fate for this particular pointer as well. Okay, node 2 and j. So here, if label of adj of node 1, actually it's good if I consider a variable new node 1 new node 2, this will be new node 1, this will be new node 2. If label of new node 1 is equal to label of new node 2, in that case we basically we increment answer by 2, and then we call the solve function for new node 1 and new node 2. Now we update the mask, basically flipping the bit at position new node 1 and 2 to 1, and that will be 1 or I think I realized something. That something is this part. Yeah, just realized that this should be 1 changed at the ith position, and this will be bit 1 shifted by this much position, right? So yeah, I hope I didn't do, yeah, I guess I did something this same mistake here. 1 should be flip or shifted by ith position here, and the same thing is going to happen here. That is 1 will be shifted by ADJ or new node 1 position. I don't know why it's lagging a bit. And the same thing is for the other position, that is 1 shifted by new node 2 position, and the OR represents the flipping. And the next thing we pass is label. One thing to notice here is what if both the nodes are same, right? I just didn't consider that case. So here let's add a condition here that if this is the case, or if ADJ of new node, or actually ADJ, or let me consider new node 1 and new node 2, if they are equal, then continue. New node 1, if it's equal to new node 2, then we continue, otherwise we do this, and by the end we return answer. Let's run this. Okay, something is not right. So let's recap it. So here this is the odd function order length, and we are passing ADJ and I as same, and we are flipping the ith bit. Here we are doing the exact same thing by for the even length. Here we are getting the new neighbor, the other center that we are considering only if label of both of them are same, incrementing by 2. We are passing the 2 nodes, and we are flipping the ith and the ADJ of ij node. So something is wrong here. So first thing is we need to pass this by reference, so that's a little optimized. Otherwise we basically traverse, we get the new node 1, we check the mask at the new node 1 position. If it is 1, then we continue, otherwise we come here, we get the other node neighbor. The new node 2 will be actually node 2 here, and not new node, and not node 1. And let's see now this works. Okay, new node, oh yeah, this should be J, I'm sorry. This works now, but this is going to TLE. We need to optimize it by minimizing it, right? So here we have uh, three states: node 1, node 2, and mask. Mask is going to be what? 2 to the power 14, right? Mask is going to be 2 to the power 14. 2 to the power 14 is what we need the space for mask, and node 1 and node 2 is going to be n itself, or n plus 1 uh, to consider some edge cases. So let's have a 3D vector. This will be resized. I'm declaring it global so that I don't pass in the function, and this will be resized by n plus 1 comma vector of int n plus 1, and this is going to be vector of int and the third space will be for mask, which will be 2 to the power 14, and all will be -1 initially. We check here if cache of node 1, node 2 and mask, if they are equal to -1. If they are not equal to -1, we return the answer. Otherwise, yeah. So let's see now. Okay, something. Yeah, semicolon was missing. Let's submit this. Time complexity. Okay, time complexity. Let's see. This will be O of, I guess, O of E. Let's say if the E are the number of edges, and this will be O of N, and for every O of N we are doing a recursion to so this will be what, O of N square into 2 to the power N, right, 2 to the power 14. So N square into 2 to the power 14, and this will be O of N, and for every equality we are doing O of N squared to the power 14. So this will be O of N cubed to the power 14, probably N to the power 4 into 2 to the power N is going to be the time complexity. I guess we can optimize this a little bit further by just not considering cases where for the even length there might be scenarios where we are considering these two to be the new center, and when I come here I again consider these two to be the center, but I guess cache will help us there. So yeah, so that's going to be the fourth problem for the contest. Thanks.